Degree of freedom refer to the number of independent pieces of information that are free to vary after imposing restrictions. Initially, the data provides an observations, but estimating parameters imposes constraints that reduces the number of independent pieces of information. Each restriction reduces the degree of freedom. In regression, fitted values are determined by estimated parameters, while residuals are obtained as the difference between observed and fitted values. Since fitted values are obtained by estimating parameters, the residuals are indirectly constrained by estimation process and therefore cannot vary freely. Hence, degree of freedom are defined in terms of residual variation rather than raw observations. For total sum of squares, the degree of freedom are n minus 1 because mean is estimated from the data, which imposes constraint that deviations from the mean must sum to 0. Once n minus 1 deviations are known, the remaining deviation is determined automatically and carries no new information. For the explained sum of squares, the degree of freedom are k minus 1 because fitted values depend on estimated parameters while regressors x are fixed. Although k parameters are estimated, one parameter, that is the intercept, is automatically used to ensure that the fitted values have same mean as the observed data. Therefore, only k-1 parameters are free to explain variation around the mean. The residual sum of squares has n-k degrees of freedom because after estimating the mean and k-1 slope parameters, only n-k independent deviations remain unexplained. The remaining residuals are constrained by the fitted model. The total variation has n-1 degrees of freedom after estimating the mean. Of these, k-1 degrees of freedom are used to explain systematic variation through regression model, and the remaining n-k degrees of freedom correspond to unexplained variation. Hence, the degrees of freedom of TSS are divided into those of ESS and RSS. Follow for upcoming videos.